Good morning, my dear students. Welcome to NALLA NARSHIMA REDDY Education Society's group of institutions, integrated campus, Hyderabad. Structural engineering, one reinforced cement concrete. Last video, we discussed about different type of structures according to purpose, according to material. There are different type of structure: residential structures, commercial structures, industrial structures. So likewise, like churches, temples, according to religion, there are various type of structures. In this video, lecture 6, we'll see some more types of structures. Frame structures, already discussed. What is frame structure? This is a frame structure connected by columns, beams, slabs, and will have different floors. How the load will transfer to the foundation? From the floors to beams, beams to columns, columns to your footings. See, from load will transfer from floor wise, okay, and also brick masonry constructions will be there to separate the rooms, and you can have partitions also. Basically, there are three types of frame structure. It's a frame, you know. See, my specs is a frame, having frame with glass. So similarly, this frame structure with maybe RCC structures, steel structures, or wooden structures. Here we will have three types of structures: wooden structures, wooden skeleton structures, say reinforced concrete skeleton structures, steel skeleton structures. See, you will see this is one of the building framed structure, consists of your column connected with beams and slabs. This is slab with beams and columns. This is one type of frame structure. This is skeleton of RCC frame structures, showing your columns, slabs, and beams. This is one of the structure. This is RCC slab under construction. So this is different type of construction, RCC construction. See, this is steel structures and also pre-cast or pre-stressed structures. So this is very easy to install, where the constructed area restricted. In urban area, generally you won't find place for material to construct practically, or flyover bridges, like your metro rail. Okay, see, all of you observed in Hyderabad, all pre-stressed members connected each other. So in these situations, these are very important, and we will see what is a pre-stressed precast structures, suspension and pre-stressed structure or precast structure. These are not heavy, only tensile stress and load bearing system, constructed in short time period, portable and modifiable, no need to framework or scaffold, large interior space available in free structures. See, suppose there is a industrial structure. The structure, the industry is closed due to various reasons, because of environment conditions and opposition from the nearby villagers or people. Then if they want to shift, it is very easy. This pre-stressed structure, it's a movable, you can modify, portable, and you need not have any framework or scaffolding work. And these materials are not heavy materials. See, this is a precast suspension bridge. This is one type of precast structure. This is a steel structure. See, these are all done by designed by our civil engineers, in the keeping in the mind safety, economy, and comfort. These are all, see, all will consider while we are designing these structures. See, observe this video carefully. You will understand what is pre-stressed structures. You will understand basic concept of precast structure. It is also important subject where will use general in constructed area restricted, and work done in short period. See, just see what is the basic concept behind this pre-stressed structure. Listen carefully.
Pre-stressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, pre-stressed concrete is being used. In pre-stressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam.
Basic principle.
The principle behind pre-stressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Pre-stressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Pre-stressing is generally done by two methods: pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensioned after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching. Stay tuned. The best is yet to come. Cut.
Yeah. See, observe this video 2 or 3 times. There are important points explained clearly. You will get definitely 1 or 2 questions in all competitive examinations. And we'll see some more tall structures in the next video.